Hello to everyone, welcome to Software Education. Today we will see the solutions of Apset 2016 paper 3 questions. See the question number 1. How many flip-flops are required to construct mod 30 counter? To construct a mod 30 counter, the mod 30 counter will count the numbers from 0 to 29. To represent this 29 into the binary format, we require the 5 bits. What are those 5 bits? Those 5 bits are called as the 1, 1, 0, 1. These are the 5 bits. So that we requires the 5 flip-flops are required to construct the mod 30 counter. So that the answer for this question is option number A. And see the next question, the question number 5. The clause in SQL that specifies that the query results should be sorted in ascending or descending order based on the values by one or more columns, right? So the answer for this question is option number B, that is order by class, right? So for example, if you want to display all the records of employee table in a order of the employee number, then the query is that select star from EMP order by ENO. Okay, so by default order is called as the ascending order. Okay, the answer for this question is option number B. Let's see the next question, the question number 6. The operation which is not considered as a basic operation in relational algebra, right? So in relational algebra, the basic operations are the select operation, and next one is the projection operation, and next one is the Cartesian product, and next one is the set differences, and last one is the unions. Okay, so that here which is not the basic operation here, that is the option number A, that is a join operation, is not the basic operation. See the next question, the question number 7. Which of the following statement is true? See the option number A, implicit cursors are not named. Yes, it is the true one, because of the oracle itself can create the implicit cursors. The user does not be able to create the implicit cursors or open, fetch and close the implicit cursors. All these activities are performed by the oracle itself. So that here the answer for this question is option number A, implicit cursors are not named. See the next question, question number 8. Assume the transaction A holds a shared lock on R if the transaction B also requests for a shared lock on R. Now see the option number A, it will result in deadlock. Option number B, it will immediately be rejected. Option C, it will immediately be granted. Option D, it will be granted as soon as it is releases by A. Right, so he has given that the two transactions, one is the transaction A and next is the transaction B, and transaction A is already hold a lock on the data item R, right? That is a shared lock. It is a shared lock on the data item R, and transaction B is also wants and requesting the shared lock on the data item R, right? At this time, the concurrency control managers can easily provide the grant permissions to the transaction B to access the shared access the data item or on the shared lock, because of here it is not the conflict operation. You know, sir, there are three types of conflict operations. One is a read-write operation, next one is a write-read, and next one is a write-write operation. In these cases only the concurrency control manager does not be allows the transactions to access the data item. Okay, so that here the transaction B can easily access the data item or for the reading purposes. So that here the option number C is the right one. Answer the next question, the question number 9. Which of the following signal have only a limited number of values? Right, the analog can have many values, but the digital have only two values, that is the 0s and 1s. So that the answer B is the right answer. And see the next question, the question number 10. The combination of port number and the IP address, it is a socket address. So that option number D is a right answer. And see the next question, the question number 11. What will be the output of this program? Right, he has given the piece of code. In this piece of code, what is the output of this one? Right, so he has given that n/n, right, so /n space n /n, right? So that here the output is the same thing, right? This is an output, because of in this printf statement nothing is wrong here. Okay, the same string would be printed. So that the answer is maybe the option number B is not be printed properly. It is an /n. Okay. And the next question, the question number 12. which of the following mode declaration is used in C++ to open a file for the input? So to open a file for the input is option number C, that is a IOS scope resolution operators IN, right? So that here option number C is a right answer. And see the next question, the question number 13. Consider the language, right? So he has given the 4 languages. Among these 4 languages we have to check that which languages are the context free languages. Okay, so see the first language 1 equal to, he has given that, so 0 to the power of I and 1 to the power of j, and he has given that I is not equal to j. Okay, so for every language we have to be find that whether this languages contains or supporting the push down automata or not. If it's suppose a push down machine, then we can be accepted. Okay, so suppose see here the i's and j's are not be equal. It means that for every zeros we have to be push the for every 0 we have to push the every 0 into the stack, and for every 1 we have to be pop the 1 zeros. For example, assume that we have the 3 zeros and we have the 4 ones. Okay, so that here the I equal to 3 and the j equal to 4. It means that you have to push the 3 zeros, and for every ones you have to be pop the 1 0, right? So that for this one you have to pop this 0, and for this one you have to be pop the second 0, and for this one you have to pop the third 0. Right now the stack is empty, but you have remains the 1. Even though if you remains the 1, this language is accepted under the context free, right? So that here the L1 is a context free. And see the next language 2, he has given that 0 to power of I and 1 to the power of j, and the I equal to j. So now consider that I equal to 3 and j equal to 3. So now we have to push the 3 zeros into the stack, the first 0, second 0 and third 0, and for every ones, right, you have to pop the 1 0. So for this one you have to pop this 0, and for this one you have to pop this 0, and for this one you have to pop this 0. Now the stack is empty, right? Now the stack is empty, right? It means that we can accept this language under the context free languages, so that L2 is also a context free. Now see the L3 language, and he has given that 0 to the power of I and 1 to the power of j, and I equal to 2. He has given the only I equal to 2. I equal to 2 means there are the 2 zeros. You have to push the 2 zeros here, and maybe j is the maybe it's 1 or the more than 2 or is equal to 2. Assume that here it is in 3. It means that there are 3 ones, so that you have to be first this two ones you have to pop the first 2 zeros, and you have to minus the 1. Now it is also the L3 is also context free languages, right? Here also the same thing, this has this one, right? So he has given that I is not equal to 2, right? It means that it is I may be of a 1 or it may be of a more than 2, right? So this type of language L4 is also a the context free languages, right? So that here all the 4 languages are the context free languages, so that the answer for this question is an option number D. And see the next question, the question number 14. Match the following, right? So if you see the left hand side and right hand side, in the left hand side you have a lexical analyzers. The lexical analyzers can be accepted by the finite automata, and the code optimizations can be done by using the DAX, and code generations, the output of the code generation is a syntax tree, and the abelian groups is the supported by the push down automata. So that here the answer for this question is option number C, right? Now see the next question, the question number 15. In comparison with the static RAM and the dynamic RAM has, right? So when you compare the static and dynamic RAM, here the option number A is the right one, that is the dynamic RAMs can consume the low powers and higher bit density. So that here the answer for this question is option number A. And see the next question, the question number 16. If A tends this not tends A alpha or beta, right, is the left recursive, then its equivalent production, or right, it is a left recursive grammar because of, if you observe here, the left side element, the top, the first left, the left side element of this production only is same as the this non-terminal, right? So that it is a left recursion grammar. So now we have to be remove this left recursion, right? So take this this production rule as into the two production rules, that is A tends A alpha, next one is A tends to the beta, right? So this left recursive grammar can be converted into the right recursive, such as that. Now take this production rules as the A tends beta A dash, and take this A dash tends, and this alpha and A dash or epsilon. Okay, if you write the epsilon, it means that A dash is also be represents an alpha. It means that A dash tends epsilon also, right? So among the given the four options here, the option number A is the right one, right? So in the place of A dash he has given R, right? So that the option number A is the right one. And see the next question, the question number 17. The language L2 equal to A to the power of n, B to the power of m, C to the power of m, D to the power of n greater than 1 and m greater than equal to 1 is context free grammar. And for this language we have to find out that what is a context free grammar among these four types of grammars. Okay, now check the first option, that is called as the S tends ASD or AAD, and next one is A tends BAC or BC. Okay, so now if you observe here, what is the language here? The language is A to the power of n, B to the power of m, and C to the power of m, and D to the power of n, and n is greater than equal to 1 and m is greater than equal to 1. Okay, so see here, A to the power of n, D to the power of n, it means that the number of A's is equal to number of D's. And if you observe here, the B to the power of m, C to the power of m, it means that number of B's is equal to the number of C's here. Okay, so now check whether the option A given grammar is suitable for this language or not. Okay, so now if you observe here, now take this second production rule first of all, that is A tends B A C. Okay, so now I am expanding this A, right? So I am expanding this A by A tends BC, here the BC, right? So here I get all the terminals, so that I cannot be expand anything here because of it doesn't contains any non-terminals. If you observe here, the number of B's and number of C's are equal here, so that here A to the power of n is equal to D to the power of that is a B to the power of m is equal to the C to the power of m. Okay, and this is the right one. Now see the next production rule, that has given that S tends ASD. Okay, and here I am expanding this S with this second production rule, that is the A tends AAD, and here this D I am writing here, this is an D. Okay, so now again I am expanding this non-terminal A with the last production rule, that is A tends BC, right? I am writing the BC here and here the 2 D's. Okay, so now here it contains all the terminals, so that I cannot be able to expand more. Okay, so now count the number of A's and number of D's here. So here number of A's are the 2's and number of D's is also with the 2's, so that here both are equal, that is A to the power of n equal to the D to the power of n. If you see here, you have the 1B and 1C, and you have to add this 1B here and you have to add the 1C here. So here the 3 B's and 3 C's, it means that you are getting the same number of B's, same number of C's, and same number of B's and same number of the D's, so that here the option number A is the right one. Now take the second grammar, that is he has given that S tends ASB or AAD, and next one is A tends CAB or CB, right? If you observe here in this grammar, what are the non-terminals? The non-terminals are, first one is this is non-terminal and this is non-terminal, and C is the non-terminal, but we doesn't have the production rule starting with the C. It means that we cannot be able to expand this non-terminal C, so that this production rule is a false one. And here also it is a false one, because of he has given the C is a non-terminal, but for the C we doesn't have the corresponding production rule. So that this option C is also the wrong one. So that among given the 4 options, option number A is the right answer. And see the next question, the question number 18. Parallelism can be achieved by which of the following levels? So right here the parallelism can be achieved by using the 2 levels. One is the instruction level and next one is a processor level. So that the answer for this question is an option number C. See the next question, question number 20. Working set model is used in memory management to implement the concept of, see the option number A, swapping, option number B, principle of locality, option C, segmentation, option D, thrashing. Right, so here the working set model is implement the concept of principle of locality. Right, principle of locality means, so at a given period of times, whatever the memory locations which is accessed by the CPU frequently, those memory locations are called as a principle of locality. It means that it is a better and it is a responsible of memory management to find out that what are the memory locations which is to be frequently accessed by the CPU, and those memory locations will be placed in a cache so that the CPU is very fasterly access those memory locations from the cache. Right, so that working set model is use the concept of the principle of locality. So that the answer for this question is a option number B. And see the next question, the question number 21. The intermediate code can be represented by, right, so intermediate code can be represented by these 3 things. First one is the syntax trees, postfix, and the 3 address code, and in addition of this we have the DAG representations also. Right, so that here the answer for this question is an option number D, all of the above. And see the next question, the question number 22. The regular expression for an identifier is given by, right, so here the regular expression for an identifier means, for example, that is your program variables, for example the integer a comma b comma c. Right, here how many variables? There are 3 variables, 3 identifiers. Right, so how these variables can be identified by the compilers? These identifiers can be recognized by the compilers by using the regular expression. Now what is the regular expression for identifying an identifier? Right, so the regular expression for this one is that L open bracket L union D close brackets and the clean closure. It means that you must have the one letter means that is an alphabet, and then you after that, after the one alphabet you may have the one or more alphabets with the combination of the 1 digit or more than the 1 digit, that is called as the clean closure. Right, so that here L of L union D, that is called as the letter of letter, or D stand for digit and close bracket the clean closure. So that here the answer for this question is option number A. And see the next question, the question number 23. An operating system uses the LRU page replacement algorithm for managing the memory. Consider the following reference strings. He has given the reference strings 1817, 82721, 83, 8213, 7137, and he has given that number of page faults. How many page faults? No, we have to calculate how many number of page faults are generated, assuming that the process has allocated the 4 page frames. Right, so there are 4 page frames, and he has given that reference string is also be given, and we have to find out that how many page fault would be occur if you go with the LRU page replacement algorithm. Okay, so initially the 4 free page frames are there, so that we have to be get the how many page faults. There are the 4 page fault, because of for the one there is no page 1 is there, so that 1 page fault will be occurred, and whenever the CPU referred the 8th page is also not be available, so that 1 more page fault would be occurred, and for the 1 no page fault would be occur because of 1 is already there in a main memory. For the 7 the page fault would be occurred, so that the 3 page faults, and for the 8 no page fault would be occurred because of 8 is available in a main memory, and for the 2 the page fault would be occurred because of 2 is not be available. So that how many page faults? There are the 4 page faults for this one. Okay, and after that the CPU refers the page number 7. The page number 7 is available in a main memory, so that no page will be occurred, and CPU refers the 2 is also available, no page will be occurred. Next the CPU refers the 1 is also available, no page will be occurred. CPU refers the 8 is also available, no page will be occurred. Next the CPU refers the page 3 is not be available, no the page fault will be occurred. Right, so that the 4 plus 1 page faults are there, and for the 3 we have to choose that among these 4 frames we have to choose any one of the page as a victim page. Right, so we are following the LRU, so that we have to see the previous references. Before this 3, the CPU refers the 8 and then the 1 and then the 2, and finally the CPU refers the 6. It means that at very late the CPU refers the 7, so that we have to choose the 7 as an victim page. In the place of 7 we have to write the 3. Now 1, 8, 3, 2. And then next CPU refers the 8 is available, no page fault would be occurred. Next CPU refers the 2, no page fault would be occurred because of 2 is available. And for the 1, no page fault. For the 3, no page fault. For the 1, no page fault. For the 7, the page fault would be occurred. Now see the previous references of the CPU. So previously before the 7, the CPU refers the 1 and then the 3 and then the 2 and finally the 8. So that we have to choose the 8 as a victim page. Right, so how many page faults? There is that another page fault, right? So here 1 and here you have to be replaced the 8 with the 7 and 3 and then the 2. Okay, after the CPU refers the 1, no page fault will be occurred because 1 is available. 3 is also available. 7 is also be available. No page faults would be occurred. So that how many page faults? The 4 plus 1 plus 1 is a 6. Totally the 6 page faults. So that option number D is the right answer. And see the next question, the question number 24. The clean room software engineering is in a process model, which is, right, see the option number A, Agile model. Agile model is not the clean room software engineering. Agile model is a very quick models in which the software developers are very highly motivated, highly qualified, highly experienced candidates. They can develop the project within the short period of time. So that Agile model is not the clean room software engineering process model. And what is see the option number B, removes the defects before they are precipitate the serious hazards, right? So that here the option number B is the right one. The clean room software engineering first find out that what are the defects are there. Defects means which is a bug which is to be found out by the customer, right? Those type of bugs will be found out by the clean room software engineering, and they have to be find those bugs and they can be remove the bugs before they can become the serious. So that here the option number B is the right one. And see the next question, the question number 25. For a function of two variables, boundary value analysis yields, right? So boundary value analysis means, boundary means here if you have to test the values at the boundaries. For example, you have a statement such as that if I is less than 10, right? Here what are the boundary values? One is that assume that here the I value is a 1, right? Here the boundary values are that is a 1 and next value is a 10. We have to check at the 1 and we have to check the value at I value as the 10, and we have to check the I value as the less than 1, that is the 0, and we have to check the this 1 plus 1, that is in 2, and here with the 9, and we have to check with the 11, right? So totally how many test cases? There are the 3 plus 3, there are 3 test cases we have to develop, right? Boundary means at the boundaries we have to check whether it contains any bugs or not. Okay, so here the boundary value analysis, there are two types. One is a function of two variables, and next one is the range variables are there. For the function of two variables, the equation is that that is called as 4 into k plus 1. Okay, so here he has given the two variables, so that here the 4 into 2 plus 1, it means that it becomes the 9, right? So that here the 4 of 2 plus 1 is not be given, so that the answer for this question is option number D, none of these. And see the next question, the question number 26. The process of constructing an object is what, and that resulting object is what? Okay, so here is a very simple one. The process of constructing an object is called as an instantiation, and the resulting object is instances. So that the answer for this question is option number C. And see the next question, the question number 27. Which of the following sorting techniques not using the swap functions, right? So in this one, the insertion sort is not be used for the swap functions, and quick sort and bubble sort are used for the swap functions. See the next question, the question number 28. The ASCII encoding of binary data, right? The ASCII encoding of binary data is the base 64. Here the answer is the option number B. And see the next question, the question number 29. Which of the following layer changes the bit into electromagnetic signal, right? So here the answer is the physical layer, right? So our data can be converted into the bits only at the physical layer, right? So that the answer is the option number A. And see the next question, the question number 30. Which of the following never suffers from the Belady's anomaly, right? So here the answer is in the both one, that is a LR page replacement and optimal page replacements does not suffer the Belady's anomaly. Belady's anomalies can be suffered in a 5-4 page replacement algorithm, so that option A is not the right answer, and option B and C both are the right. In this both are never suffers the Belady's anomaly. Okay. See the next question, the question number 31. Any member functions can find out the address of the object of which is a member, right? Here the answer is this member function. Okay. See the next question, question number 33. The range of the frequencies transmitted without being strongly attenuated is called. It is the bandwidth. Here the option number C is the right one. See the next question, the question number 35 matches the following. OLAP is related to the data warehouse, and OLTP is related to the RDBMS, and decision tree is related to the classifications, and neural networks is related to the regression. So that here the answer for this question is the option number A. And see the next question, question number 38. What parser satisfies the LL of one grammar? The answer is that is called as a top-down parser. Top-down parsers can satisfy the LL of one grammars, and bottom-up parsers can support the LR grammars. Okay, so that here the answer is option number C. And see the next question, the question number 39. When a class serves as a base class for many derived classes, this situation is called as the hierarchical inheritance. When a class is base class for many derived classes, then it is called as hierarchical classes. And see the next question, the question number 40. Which of the following algorithms solves the all pair shortest path problem? Right here the answer is the Floyd's algorithms is used to solve the all pair shortest path. Okay, and Dijikra's algorithms is the single source shortest path. Single source shortest path. And the Prim's algorithms for the spanning trees. Okay.